All right. Welcome back, everybody. This is the final session of becoming an institution level cyber infrastructure leader, the 2025 workshop. It is Thursday, August 7th, 2025. This is low cost solutions for hardware. Our moderator is Melissa Lawrence from the University of Iowa, and I'm going to turn the show over to Melissa to introduce the panelists.
Good afternoon, everybody. I'm Melissa Lawrence. I'm the Associate Director for ITS Research Services at the University of Iowa. I'm here to help moderate the panel to discuss low-cost hardware. We considered, that low cost for research computing hardware, including potentially repurposing used hardware, extending the life of existing systems, and leveraging other resources to help facilitate low-cost research. So with that, I will start off with having the panel introduce themselves. And Mike, you're the next little slide on my window. So
Hey, Mike Renfro, Tennessee Tech University. Uh, I've been doing some of this for a while in some way or another. I've been in central IT for just at 8 years, 17 years prior to that in a research center, and been doing some level of IT work around science and engineering, research and education for about 30 at this point. We're small.
thanks, Mike. Jeremy?
Good afternoon. I'm Jeremy Everett. I'm at Southwestern Oklahoma State University, and my day-to-day job is teaching Computer Science 1 and Computer Science 2 to the freshmen. But in my part-time job, I get to play with as much hardware as I can get my hands on and hang out with the coolest people I know.
Thank you. Dan?
I'm pretty sure he wasn't referring to me. So I'm Danny Andreessen. I am newly minted department head of computer science at Kansas State University. Been on the job about a month, so I'm still in the stage where I can shrug my shoulders and say, I have no idea. And it's expected. I've also been the director of our HPC Center for a good 20 some plus years as it grew out of and as a career award. And so it's oddly placed. It's neither reports to central IT nor the VPR. It's part of the College of Engineering. But yeah, I had a lot of fun over the years scrimping and saving and scrapping and providing some highly unorthodox solutions to keeping the hardware cheap.
Okay. Swatha?
Hi everyone, good afternoon. I'm Shash. I work as a research scientist at the George Washington University. It's been 6 years now. So I work within the IT department very closely with the researcher. So I work with the RTS department. Our complete team focus mainly on supporting the researcher, basically to provide the effective use of high performance computing. So as we can understand, providing a customized solution. This job, of course, full-time job, playing with the new devices as well as the old devices too. So that is the part of it. But yeah, I was working at Caltech before, supporting their tier 2 cluster. And let's see, Grid, I had a various opportunity to work and collaborate with ESNet, Department of Energy. Yes.
Thank you. Brian?
I'm Ryan Dahl, Wichita State University. I teach in the College of Engineering for computer
Having a
architecture.
hard time hearing you, Ryan. I'm not sure if that's the same for everybody else.
Is that any better?
Yeah, a little
Awesome.
bit.
All right, so I'm Ryan Dahl of Wichita State University. I've been here a couple of years, teaching the College of Engineering, computer architecture, primarily cloud computing. And then prior to that, I spent a number of years in industry, working for different companies like IBM and different VARs and stuff, cloud providers. So coming in that. I also serve as Deputy Director for High Performance Computing here, focusing on architecture, design, and planning. However, you can also say I'm the unofficial chief scrounger.
Chris, you're next.
Hi there, can you hear me okay? Yeah, Chris Coffey. I'm the director of our Advanced Research Computing Group at Northern Arizona University. And I've been at NAU for 10 years and the director for 2 years. And I've been supporting researchers for 95% of my career, I think just a little over 20 years. So seeing what works and what doesn't work.
And then last is Tom.
Howdy, everybody. Tom Cheatham, University of Utah. Been using computers since I was in high school. We had to date me a little bit. We had a PDB-10 from DEC in our high school, which is kind of rare. And been a professor here in medicinal chemistry for 25 years and director of our High Performance Computing Center for the past 11 years, although I'm on administrative leave. We don't want to talk about that, but that's what's happening.
All right. First question here, and we will start off with Jeremy, if you want to start us off with this one. So, what is considered a low cost solution, and what is considered low enough for the cost?
Okay, so this is an unfair advantage that Oklahoma has, but for us, low cost is Henry Neiman wrote the grant for his system at OU. And when he does that, he tells the National Science Foundation that, by the way, if you give us this system, we're going to let anybody in the state that has a .edu email address have access to our system. And so low cost for us is OU pays for the power, cooling, and the NSF bought the hardware, and my university, my students use it at no cost. That's been a great model, and I feel like that's helped them be more competitive on grant writing. And it also has enabled me to have several students here at my university get on a supercomputer and start running jobs that we didn't actually have to do anything financially to support them. And so, in fact, last spring, my software engineering class was doing a project related to benchmarking the National Weather Center weather research and forecasting model. And my students did that. Henry's team spun up profiles for all my students so they could get on the system, share, have a shared group account, and get their work done at no cost to my university. We've got similar agreements with Pratul at Oklahoma State University, Evan Lunley at UCO, and Franklin out at Langston, and Stephen Wheat up at Oral Roberts. And if we need to, we have also got access to Carl Frankel's system down at Southeastern. The other thing that we've done is we've also been just donated hardware. And for that, we're talking about hundreds of thousands of dollars of equipment that has come in on U-Haul trucks and semis, where we literally just had to pay the shipping. And then if you look at what that stuff is worth on eBay, it's worth hundreds of thousands of dollars. And that's the stuff that I put my students on that we can start learning how to do system administration with. Does that?
Yeah. Any volunteers for taking additional on that one?
Now that I reiterate what he said, it's if you can get someone to donate stuff. So we have a hospital system here, large equipment, and they run them for 3 years. Well, we run our clusters for 10 years, and so we get their 3-year-old hardware and put it in. Now it is a power expense, power heavy, but if we have the space, why not do it? The other thing I would say is that we don't go to Best Buy or whatever to get hardware. We want something that's a little more reliable, that you can do remote sysadmin access with IPMI and other things. So we go to providers like Dell, Atipia, Lenovo, even though Lenovo's not good for some contracts these days. But and we make the vendors bid off each other and take the lowest price, and that's been very effective.
So at GW, we actually believe repurposing over replacement. So we did have an old cluster, Colonial 1 cluster, and we did have a Pegasus one, so which was up and running. So everyone wanted to use the old cluster. But we came up with a strategical thinking, how exactly can we reuse the system? So we took all the old hardware. We did have like 48 old Dell R7 chassis, like 6,800 chassis, and like old GPU, like, K series. So we started dividing them into different cluster, I would say, like a teaching cluster where it is also called Cerberus. So it's only mainly for teaching purpose. So in summer, we can actually reuse that, entire cluster for teaching. And we divided into Raptor cluster where the junior comes in or a system admin wants to play around as a test bed, So we could actually implement that, or like, if you have new, like, Werewolf, just to play around and see whether it works for us as a system admin too. It will be very useful just to go out under production and start working. That will be difficult. So something like a test environment, reusing the old cluster was very effective. And also we used as a wiper, it's one of the cluster where we use OST as a part of OST grid right now. So I think it's repurposing has really helped us. But again, it boils down to the employee's time, like, how effectively we can use it. So, yeah.
Well, now I feel left out, but now people are making me think of other options for what low cost means. So like our test beds, I don't have physical ones. Week one, every one of my student workers, I have them build an OpenHPC cluster from the install guide in what used to be 10 gigabytes of RAM on their laptop. I think it's a little bit beefier than that now, but it's generally pretty feasible. And our production-ish test beds are at no cost to me. And again, they're just virtual, they're just living in our enterprise virtualization environment. And we can do as much beat up and tear down as we need to in there, as long as we're not having to worry about, the physical hardware or like benchmarking performance.
Yeah, I'd also say that people like to use local resources. We have a hard time getting people to use national resources. The barrier's not that hard these days to get into Access or to get into Nair for the machine learning AI stuff, and that's totally free.
Yeah, so we echo some of the other points. Typically, what we've done is we've gone after an MRI about every 3 to 4 years for a nice hardware bump. In between, we go condo. So we have the latest and greatest that's precisely tuned to our researchers' needs. But some of the things we have done, like Thomas, for instance, you mentioned, we happily trade off and say we don't care if we're running a Lenovo or Dell or HP, whoever gives us the best value at the time. And like Shashi, you said that you have to trade off against your people's time. But we have a fairly flexible middle layer of management that just says, oh, new type of machine, great, we'll automatically generate the OS image for it. And so we have, compute nodes that are 9, 10 years old, like you were doing, Thomas, that work just fine. And so let's keep using them. One of the other things we've done is made heavy duty use of eBay. It's one of the nice things about not being part of central IT. We can. So we don't get consumer grade, it's enterprise grade. But I remember one time, for instance, we needed an InfiniBand switch and we saw one for $1,500 on eBay. And we're like, okay, this is too good to be true because these were going for 18 grand at the time. But we thought, well, it's cheap enough that even if the guy's running a scam, we're only at $1,500. Let's try it. And it came, and it was a brand new Mellanox InfiniBand $18,000 switch, never taken out of the box. And we looked at the seller's other equipment, and it was a bunch of evidently he had just taken over somebody's old chemistry lab and just bought the whole thing and was parting it on an eBay. So beakers and flasks and racks, and he had no idea what it was worth, and he just stuck it on eBay. So we got 90+% off. Similar, and so most of our network switches in our system we got through eBay because they're fantastically cheap, but they're all but we kept it consistent, so they're all Mellanox, blah blah blah. So managing them really hasn't been a big deal. One of my other favorite things was we needed 12 new racks at a time. And so we looked around and found a surplus dealer up in Lincoln, Nebraska that had a bunch of old IBM racks. They were really nice racks. And we said, well, we need 12. How much would it cost us? And he said, well, do you need paneling on the sides? And we were like, not for the internal racks. I mean, the ends, yeah, we want some paneling, but internally we don't care. And he said, okay, tell you what, I'll sell you the 4 corner racks with paneling for $300 each, and I will give you the other 8 for free. And we're like, sold. And so we had, our row of 6 racks, and he gave us the front and back, grilled panels, and so everything looked good. And so we got 12 racks for $100 each, and these were excellent condition IBM 42U racks, and they're still in our data center and cranking away, and it was just a fantastic deal. So by using some non-traditional purchasing mechanisms, you can get some really good deals and still have excellent quality hardware and other materials that you're working with.
Yeah, I think a lot of low cost really is more about being creative and stretching the budget and helping researchers and students find resources that they need, maybe weren't able to easily find stuff. So, echoing Dan's deal, we actually had a company that was here in town that was refurbishing one of the data centers, and we got them to donate 12 racks, which is what we're using to expand our on-prem OpenStack cluster. We also are kind of looking at some of the challenges too. If one of our HPC clusters is like, hey, you could buy in, but the minimum buy-in for like a GPU server is $30,000, $40,000. It wasn't very flexible. But we had faculty say, well, I got a grant for $5,000 and I need a GPU. So we started buying a few nodes, found a few refurbished nodes that we could get, and we started saying, hey, if you just have a GPU, we got slots. We can put it in some of these nodes. So it's being creative and trying to get the best value for the money for what you're trying to do for your people.
I think this is kind of a good segue, and we've touched on this a little bit, but for our next question, how can an institution procure resources that are low cost or free?
I think we are many funds out there, like, NSF funds, so CC Star proposal or access for that matter, like, or I think like some of the private foundations, like, Google and all also provide funding. Or if you have a local state, like, in Virginia, we do have grants, like, university can actually write to them, non-profit. So you can get grants from there. And AWS too actually has a non-profit, like, credit program where we can use the cloud for a very low price.
Yeah, and I'm going to say check with your institutional rules. There's often different things that are there, but we've gone out with a lot of our local companies. Many of them that are hiring our students said, "Hey, how can we better prepare our students?" And by the way, here's some of the challenges we have. And we've gotten donated equipment. Now we have to run the donation request through our foundation to get the tax write-offs and stuff. But know and understand kind of like what your processes are, how to do it. But look internally for used equipment, repurposing stuff. We're in the process of upgrading some labs, so I'm pulling the GPUs out of there and sticking it in one of our clusters. That way, students don't necessarily have to go to the labs and stuff that's there for that. Work with your local businesses to find some of the resources. Also, be flexible where you can be. We actually just bought some server equipment from Lenovo, and they said, well, you're asking for 964 AMD EPYC Gen 5s, but we've got a fire sale going on, the 72 core ones. And we actually ended up being able to get a couple of more servers with better CPU core to memory bandwidth by going with the 72 cores instead of the 96 for about the same money. So if you're working with your vendors, don't be afraid to ask them, hey, do you have any refurbished stuff? Do you have, things that are maybe on sale or on discount, clearancing things, and just work with them.
So I've got a follow on to Ryan's story. I was actually sitting in one of Henry's supercomputing expos, and this is probably 7, 8 years ago. And one of our vendors emailed me and said, hey, we just had a buyer back out of an HPC cluster. Would you be interested? And I said, of course. And so he said, we'll sell you 120 nodes. This 120 node cluster, we'll sell them to you for about 3 grand each per node, but you have to take all 120 nodes. And this is not the sort of money I have just casually sitting around in my bank account. And so I said, give me 30 minutes. And so I sent a blast out to our user list saying, is anybody interested in buying a nodes? Within 10 minutes, I was oversubscribed. And in the meantime, Henry is happily talking about, how many zillion researchers and papers that his systems have produced. But I was pretty happy with my 120 nodes. Got back to the vendor, snagged all 120 nodes at a bargain basement price, and had a bunch of unhappy users that, why didn't you talk to me first? Like, sorry, you were beaten to the punch. But developing good relationships with your vendors can lead to the unusual, hey, I've got this situation, can you help me out? And if they know you're looking for a deal, a lot of times they've come up with some pretty good stuff.
I'd also say don't trust your institution to be cost effective. The enterprise IT is normally not cost effective at all. We have to be in research computing because we don't have sustainable budgets. We're supporting, in my case, 1,000 PIs, 7,000 researchers with a lot of stuff. My institution hasn't really supported us. So be creative, as Dan said.
Anyone else on ways that you can work with your institution to procure resources that are lower cost or collaborations like Jeremy was talking about?
I had one other thing. Our most recent, so one of our issues at the moment is that most of our nodes are condo models owned by various research groups, and we don't have many that are just generally available. And so our VPR's office had an internal competition that said, hey, we'll kick in half for anything that is a general, essentially a mini MRI. So general research instrument. And we said, hey, can we count? And they said, sure. So they ended up paying for half of a $70,000 GPU server that's available for everybody on campus. And coming up with 30 grand for me is a heck of a lot easier than coming up with 70 grand. And so keeping an eye on internal competitions and keeping in, whispering in your VPR or central IT, whoever CIO's ear that, hey, we're worthwhile if you've got some stuff that's generally out there. And a lot of times it's more defensible for them to say, this was an open competition. Anybody on campus could get access to this way of helping researchers. They just happen to win, rather than it looking like favoritism when they, hand us in our state of starvation. Oh, here's a morsel. But the politics play a role in this type of thing.
All right, move on to the next question and maybe have Mike get us started with this one. What low-cost resources help meet researchers' needs?
Yeah, so I, I'm gonna be all fancy and say requirements analysis with your researchers, basically. Um, you know, for the longest time, my people, my user base, they were running CPU codes. They ran as fast as they ran. I made them run, as parallel as we could. But the thing is that especially as we've started getting more people into LLMs and AI, and especially the LLMs, either their models fit into a GPU or they don't at the quantization that they want to operate at. Okay. So, the guy that, the one set of users that might be perfectly fine with my 8-year-old CPUs in my old cluster, um, because the job might run, maybe the job runs 50% as fast as it does on my brand new ones, but they still get that much more work done than they would by doing it on their own. They're probably just fine. My kid that needed, four 40 gig A100s to run his LLM at the full thing, he was not going to live with my old GPUs or anything else. So there's going to be some things where you can meet their needs with compromises with old stuff, and then there's other places where it's just not. And so look at everything on kind of a case by case basis.
Anna did
I think
turn that question.
another thing
Oh,
that I was going to say, I think another thing that really plays well is work with your researchers to really try and understand what they're doing. In some cases, there may be better ways to get things done or just more creative solutions. So, one thing we found with the LLMs and some of the models is with some of the newer generation CPUs like the AMD EPYC 5s and stuff, where we can actually run some of those LLMs if they get the right model or code it right on the CPUs rather than GPUs. We also have some FPGA resources that we have that's there that will run certain things that we've got developed too. So sometimes they're just saying, oh, well, they're asking for this, but let's really see what you're doing and see where we can find resources. Maybe it's outside the institution, but sometimes it's just you'd be surprised how much just a little bit of code cleanup and working with them to maybe figure out how they can better cache their data or something like that can make wonders in being able to get it to work on smaller hardware.
Yeah, adding to what Ryan said, audit. So we go check, like, oh, this guy's only using one core out of the 124 cores that are available. Why don't we go tell them how to do 124 jobs at the same time? And these kind of things. So a lot of monitoring and investigation. We're looking at GPU performance, other things, and because people just don't know. I mean, researcher just wants to get the science done. They don't really care about the performance. They just want to get it done. And with the new hardware, we have these H200s. people don't need an H200. They can get by with an old GPU and have that work. Okay, I'll stop there.
Yeah, and one other thing too that's kind of interesting is, there's the old grid computing stuff too. So we've been looking at taking some of our engineering labs. We were upgrading new systems to be Windows 11 and compliant stuff. Some of these labs have 60 plus machines in there with, A4000 type GPUs and stuff like that that are fine for running mid-tier loads. So we're working on trying to get it set up so that we've got our own little grid computing system, and you just look past HPC. HPC is great, but sometimes a grid computing system or Kubernetes cluster, just being able to say, oh well, we've got these other resources. How do we deploy onto some of that stuff? So we're playing around with Slinky, which lets us take some of the stuff from our HPC systems, put into with the Kubernetes with Kubeflow and things like that. So just being out there and kind of staying in touch with some of the things that are going on, or just seeing what else you got resources. Go, how can I leverage that? How can I use that?
Yeah, I would say, as long as it's faster, cheaper, more reliable than what the researcher has access to, I mean, I think that's kind of meet their needs, right? I've heard of centers buying desktop GPUs and hooking them up to their cluster and having good success with that, even though they're only single precision or whatnot, but things like that.
Kind of to look at this question from a different way based on something that Tom said. How do you educate users or work with them to help them utilize maybe older technologies that would still meet their needs? There's a tendency for people to want to try the new and the greatest, even though it might not be what they need.
I would say we have a hard time getting people to use the new stuff, to tell you the truth. They're used to the old way and they like it and it works. So they just use it. And it's a funny thing. I've got a large HPC center on my campus. There's a lot of people that don't know we exist and that we have CPU resources for free and storage resources for free. We constantly are trying to educate people about it, but they're like, no, I just want to build it in my lab. Well, that's not going to be security compliant. That's not going to, you're going to have a graduate student you're going to have to put dedicated to running this thing. Um, yeah, I don't think I answered the question though.
I want to add to that that I was one of those students when I was doing my graduate program, that I was literally across the lawn from the supercomputing center. But the entire 7 years I was on campus, I never went to see it or never used it, even though I should have been using it.
I think
Yeah,
the researcher will be
go
very
ahead.
comfortable, when you're using your own model. So they feel very comfortable. They don't want to come out of that particular zone. So I think as we belong here and we know more about HPC. So it's better that we sort of make them comfortable and show them how to use it. Sometimes they think cheaper stuff is it's cheap, low cost is cheap. So it's not really that, little bit upgrade does a lot for them in their research. I think having that kind of support is very important, and giving the comfort, telling that it is reliable is very important for the researcher.
That's one of the things that, for instance, Thomas mentioned, and I put it in chat. One of my staff members, Dave Turner, who's from Iowa State. Sorry, Melissa, originally. But one of the things he does is he's got a tool called KStat, which interacts with Slurm and some of the other things, and tells you, okay, lists off, and particularly if you're an admin, lists off everybody their jobs and automatically color codes. Are they dramatically under or over or close to the limits they asked for? And so one of the things we do manually on a daily basis is just check to see whose jobs are running, and are they using a lot less in particular than they asked for, because our users are terrible at estimating how many gigabytes of RAM and how many cores they actually need for a job. And so one of the things we tend to do is we manually use tools like KStat, and then we get in touch with them and say, hey, it looks like you're only using one core instead of the 32 you asked for. What's going on? And a lot of times it's just an accident. Sometimes it's legit where they have a tool chain running, and this particular step in the tool chain only needs one core, but the next step needs everything. And so it can be a real educational experience. The other thing that we've had trouble doing, that we try to teach our students, is essentially use stochastic parameter sweeps. So in the sense of, if 90% of your jobs only need 5 gigabytes of RAM, but you don't 10% you don't know which need 30 gigabytes of RAM, just run all of them. And then the 10% that get killed, go back and rerun those with the 30 gigabytes or so, because overall net, you're actually going to get through a lot faster running a bunch of small jobs than a bunch of big jobs and wasting 80% of the request. And this takes a substantial change in the mindset for them because they're used to every job is a pet and they want to pet it and monitor it and everything's great. And you have to, as a friend of mine says, you have to convert pets into livestock. It's just you want to do it in mass and go from there. And I will repost the link.
Yeah, I think part of it is as soon as they see the payoff,
Mhm.
they're going to be convinced, and hopefully word of mouth is going to take off. You
Yeah,
know,
it has to be worth it for them.
yeah, and so when you can be, and again, I told my student worker, that's currently right now probably working with, chemistry kids on a Python script to make job scripts to make Gaussian runs will happen. We don't have to be, we don't have to be geniuses and experts on everything. We just have to be better than they are uh, at certain things. And, this group that he's working with, they know that they've got some things they can automate, but, there's things that they can improve as well. And, where this little workflow came into my attention was kid says, "Hey, I need more than 7 days to run this job." Okay, fine. Why? And I finally look at his input file, like, where did this come from? Because you're not actually using more than one core. How about we try and make this run on 96? And he's so much happier now. And that then led to today's meeting where they're going to fix this script and make it a little bit more maintainable and useful for everybody.
So we've talked, a few folks have mentioned this a little bit, but in thinking about, lower cost solutions for hardware, repurposing hardware, how does your institution account for, the total cost of ownership and how to reduce some of that overhead? So maintaining a system that's out of warranty, how do you deal with parts, staff time?
So at our institution, it's on the faculty and it's just considered if you want it, you're going to go build it. But as programs get bigger, I know Evan from earlier in the week was a good example. Then once the program gets bigger and more grant funding is coming through, then they get more FTEs. So you kind of just have to start wherever you are.
I mean, for us, to some degree, we're a black box to our institution. Money flows in, and we support a bunch of researchers. But on the other hand, as multiple people have mentioned, every decision we make is driven by the trade-off of, okay, how much money am I saving versus how much money am I spending in terms of salary for my staff, and is it worth it or not? And so, and this is something that regularly, if we're doing something that's going to change how we do things, it's like, okay, sure, I can save some money here on the hardware, but if this is going to make your lives miserable, we are not going to do this. I mean, we could go cheaper and have a completely heterogeneous networking system, and I would have multiple job openings open on my website shortly. And since I really like my people, it's definitely a trade-off to say, okay, so what's the level of tolerance you have because we really want to serve our users in the best way possible. Now, on the day, which is probably coming moderately soon, where they start also saying, oh, and by the way, you need to pay for all the electricity you're using. Obviously, a lot of the old hardware argument is going to be the equation is going to shift because it's more cost effective net to do like what Georgia Tech did, which is buy out all of their existing users and spend $10 million and get a whole bunch of new machines because net TCO, it was actually cheaper than running a bunch of old machines. On the other hand, the odds of me getting 10 million even in a loan out of my institution, it's a very round number.
Yeah, I think that's an excellent point Dan made about, running low cost solutions and the cost it has on your staff, and especially when it's harder and harder to find the staff these days. So I think you have to consider that. Are your staff going to be, awake all night trying to run this thing that's broken, et cetera, instead of calling on a vendor to fix it, et cetera? And with diminishing budgets for staff, at least at NAU and similar universities, I think you have to think a little more carefully about running some of these low-cost solutions.
Yeah, I mean, as was alluded to in our super secret panelist notes to be found in the call document for this session. Um, I think it's, and again, I think of everything from the small shop perspective, and I recognize there are even smaller shops than me, but I just go with what I know. Is you know, sometimes what's cheap in hardware may come at a mental health or other sustainability cost for your people. Even if they don't quit, they may be stressed out, that it may compound into some other things. Um, and and especially if you're like the only one if you're only the only one in the responsibility chain, you especially probably if you're in this kind of work field line of work, you probably do feel extra responsible. You want things to be up. Henry says, and correctly, I assume that 95% uptime is just fine for the NSF, you know, but boy, I was not the kid nor the young nor the adult that would live with 95% uptime. I wanted that thing to be up 24/7 because that was a point of pride for me, even if nobody else was exactly asking it for me. And so sometimes not having the completely bespoke solution can either let you leverage other people in the organization or the vendor or some other community to where it's not literally all sitting on your back.
And use cases play a lot too. If we've got researchers that are like, hey, I got this big pool of money, but I'm running this computational fluid dynamics thing that's, for co-solvers and stuff and taking weeks to run, and the outage is very disruptive to them versus a student that's just trying to learn Slurm as part of a class or something like that's a little different. So being able to group your hardware, and what we're doing in one of our clusters is we've got, hey, the high end stuff here. That's the researcher pool. We've got a small jobs pool where other things are running on lower end hardware. So that way, if there's a disruption there, it doesn't impact the high queue for the higher end machines. And it also takes those workloads out of the queue to get those jobs started faster. Um, so, when you start looking at things, though, too, is there are places you can save some money even when you're buying newer stuff if you think carefully. If you've got single points of failure, you've got storage arrays, stuff like that, that's probably where you want to invest more of the warranty stuff. But on your regular compute nodes, especially the non GPU ones, what we found sometimes is going with like the bronze level next business day or 3D and replacement stuff will save you a lot of money to the point where you could buy a few more nodes and have that money being productive instead of just wasted on a insurance policy in case they die. You also think about mean time between failure of some of these components and looking at some of the analytics and stuff. We've often found that sometimes it's cheaper just to buy a spare hard drive or two, or just say, hey, the risk is I'm going to have an NVMe drive go out and it's going to be, $600 for one of these here, but their cost of, doing the extended warranties and all this other stuff on those systems, the odds of the whole thing dying are pretty small. So yeah, it's a trade-off, but that's some of the things that you can do to stretch your budget.
I agree with all the panelists there. But to add to this, I feel there should be a proper management too, because you can't just keep on adding system because sometimes security risk is very like, you can't patch it too. So you need to be very mindful of what we are doing since it's all self-supported, like, employees time is there. So just because they are doing something doesn't mean that we can use it. So that's very key point to remember.
This
Yeah,
question's
we
come up
we
in the
recently we recently had to take down some nodes because they're their ROMs were so old, their firmware was so old that they couldn't handle blah blah secure boot blah blah, which was required by university policy. And so it was just like, okay, yeah, I mean this is the cost we pay for old machines, but we want to keep everybody happy, particularly on the security side. So this is what we did.
Yeah, and we've pulled a few out too. And when we get some of the servers that are donated, we split them into a couple of categories. Stuff that's good to go into a cluster and stuff that we have for like hands-on training. So we teach our students, hey, here's how we can go build a cluster. Here's how you install a GPU. Here's how you set up a network. And sometimes the older machines, some of those are just better off in that type of an environment. You're still getting use out of them, and you're training up the next level of students and workers for your talent pipeline.
I think the old system doesn't even support IPv6 sometimes. Like, if you want to do single stack, then IPMI doesn't even support. So even that is very important consideration. My director is fond of IPv6. So yeah.
This question's come up in the chat, and I think it was answered a little bit, but questions about warranties for repurposed hardware or eBay hardware or out of end of life past the 5 year standard hardware agreement. What are strategies to help continuing to maintain life in those systems past warranty?
Yeah, I mentioned in chat, we negotiate now for 7 year warranties for everything but GPUs. GPUs and video will only do for like 3. But and then we look to extended warranties, mostly on storage, because users don't ever want to give up their storage ever. And so you can get a 2 year extension for not much money, a lot cheaper than replacing. And so that's the route we go. We don't usually extended warranty the CPUs because we just have a policy: if they die, they die. We'll run them until they die.
Yeah, we third parties, we generally get the minimum on compute nodes from the vendor. So like 3 year next business day. They're not single points of failure. It is comparatively dirt cheap for us to put that on third party service after the 3 years. And I have very, very rarely had to exercise that. But it's absolutely been worth it from a less hassle perspective to have that. But storage, InfiniBand switches, that kind of thing, where if they die, everybody notices. Yeah, they get a little bit more priority in the budget.
And do some cost comparisons too. We've got some blade servers in one of our clusters, and that third party warranty was about $400 per node per year for some of those. And we talked with one of the reused referred equipment vendors, and like, well, we could probably sell you an entire node for that. So we decided when we re up the extended warranty, we did it on the storage portion, we did it on the network, we did it on a couple of head nodes there, and then we didn't on the rest of the blades.
Yeah, and as some folks have already mentioned, I feel like warranties are not quite as important for the compute nodes, but we'll just keep, cold spares on hand for memory modules and SSDs and power supplies, and get them brought back up real quick, and then look at serversupply.com for cheap parts to replace them with.
Yeah, and as I mentioned on chat, particularly in our networking, depending on licensing rules, a decent hunk of the time, for instance, as long as we have a license to download the security patches, we don't necessarily have to have all of our network switches under warranty or under a software contract, something like that. But there are some things like that where it's like, okay, we will keep them under contract for it's specifically for the security side. But in terms of the actual hardware, it's so cheap to get an additional switch that we just keep one in cold storage and swap it in. And like the others have said, next business day is as good as we get, and frequently within 3 days or so is fine, especially on the compute side.
So to add with that Pegasus cluster, which is our main HPC cluster, we do have to make a network upgrade for that. Like, we do need to have a warranty. So we go with fs.com for like, all layer 2 stuff because it's very clear. Like, for layer 3, we go for Arista. So I think it's low cost solution, but yeah, it works for us with warranty.
And you want to toss the link to that in chat since we're tossing other links for favorite places?
Oh yeah.
Yeah, we have mostly a whole lot of our cabling comes out of FS more than our switches do, at least across the enterprise. But yeah, if I get a replacement cable because one died, yeah, it comes from FS.
We use Colfax Direct a lot.
We have different varieties of FS, 140, 10, 1, everything, and it works good. Sometimes we need like, some type of upgrade and then they fix it immediately. They send you a software, like on a firmware, which does it. So you have to tell them the IP doesn't work, IPv6 doesn't work, this doesn't work. And I think it's okay. It's doing its job.
Kind of moving on, when do you choose to have kind of a DIY approach versus going potentially with a vendor to save, cost or time? How do you make those evaluations?
Well, when Oracle came to us and said, hey, the scheduling software you're using at the time is going to cost you $1 million a year for your licensing fees. That was a really easy decision to make to roll our own and go open source. So, for a lot of things, if you add the word enterprise to it, it immediately becomes completely impractical. And then it's just a matter of, okay, what's the level of cost? What level of pain are you willing to trade off in your wallet versus your staff?
Yeah, roll it yourself if you can, but that does require staff, and that's the key. If you don't have the staff, sometimes you've got to go for a turnkey. We try to avoid that at all costs, but
And also piggybacking on enterprise can be useful. Like, all of our security stuff is just we have a campus site license for. But on the other hand, and for instance, our Intel compiler license and some of those other things, it's like, yeah, it's worth it to have the latest version, and it's relatively cost effective. But I think all of our software stack in terms of management and the OS and stuff is free and open source.
Yeah, and if you look at things like the CC Star grants and other things too, many of them have caveats about not paying for licensing and preferences for open source software and stuff too. So we had a storage cluster that was there and quoted by an outside vendor for about $500,000. And we looked at it and said, "But we can roll our own Ceph cluster for about $100,000 there." And we decided to do it because we had the resources, but it did take us several months to get it stood up and through some of the testing. We're actually in the process of getting that in production. So you do have to think about, is this something that's critical from a time standpoint? You got to think about what's the time it takes there, what's the risk and experience that you have with it there, but also think strategically too. We're part of a community, so if we can leverage open source tools like Open on Demand and other things that we've as a community kind of invested in, then that just continues to strengthen the community. There's also a lot of good help that's out there, and sometimes, shout out to Dan and his team, they help us with some of our clusters here at Wichita State. So, think about the partnerships that you have, the local REN networks. I know in Oklahoma there's a lot. We've got Canron here, we've got the GPN. So being able to say, well, we're thinking about the decision, reach out to other institutions that you got connections with, see what success they've had with some of the projects. Maybe they even have some resources that they can help you with too. So you kind of want to think your way through it. It's like, okay, what's my risk? How can I mitigate that risk? What's the cost savings? If there's not that much cost savings and it adds a lot of load, maybe it's not worth it. But our feeling really is most of the time, DIY it whenever and wherever you can.
But talking about stress to staff, we were a Red Hat shop. Red Hat changed its licensing. We moved to CentOS. CentOS changed its streaming model. We had to move to Rocky 8 and 9. And this has caused months of my staff time to do that. Now we have the VMware fiasco because VMware has upcharged all their stuff for virtual machine management for moving to Proxmox, and all this stuff takes a lot of time. And you have a new boss comes in and says, "Hey, I want you to do this new thing. I want you to do this private cloud." And I was like, "I don't have time. We're doing all these upgrades, and then you want me to have NIST 800-171 compliance and all this other stuff." Yeah, it's challenging.
See, the good news with being under-resourced is, for the most part, I never had access to a lot of the stuff that we had to pay for. Um, so, I built clusters on Debian long before I moved into central IT. And so, yeah, it's a whole lot more comfort zone for me, especially to do a DIY on bits of software because, there is no acquisition cost to it. I can very often stand up a little test case somewhere in practically no time. And as long as this piece of software needs to do this one thing or one set of things, you know, the blast radius is a whole lot more contained in terms of what could happen if that one piece of software goes out. Uh, Open on demand might be the exception there because if it goes down, I hear about it. Um, I would hear about that more probably than I heard about a node going out.
Yeah, we love open on demand. It's used by a lot of our course masters for their classes and things and standing up stuff. And it's just an easy way for people that don't know Unix or command line to get into computing.
Yeah, open on demand's great.
Until it becomes non-free, if that ever happens. Let's hope not.
I hope not.
Road trip to Columbus, if that's the case.
Oh, so next question is, uh, how would you recommend folks learn to be good users of free resources from other institutions? Or finding out about those resources?
Perk is a great resource. The Park and Campus Champions mailing list is a great place to get started. Um, Ryan was just listing off GPN, whoever your local optical network can or it is for Kansas. Have Henry blast his email list, which I think is approximately a third the size of the North American population. Go with whatever works, but particularly in our field, people are really happy to help, and it's always good for the soul to feel like, hey, somebody wants me to be opinionated and values my opinion. And so for a lot of people, they are very willing to say, hey, this is what I'm using. These are my pain points. This is how it works. And if you average over a couple different inputs like that, you'll probably come up with a pretty good solution. I will say that in general, the bog standard solution for 90% of us that we're running in terms of, was CentOS, now it's Rocky. We're probably running Slurm. The more compatibility you have with the access and exceed machines, the easier it is for your users to shift when their needs go up. Easier it is to find training materials because, hey, they're available and, you can hop on and ask people about it. You've got more variation on the file system side. Like on the debate that was happening over the last few days between the various file systems, and it's kind of okay. What are you prioritizing? Cost and performance and scalability. Choose two, that sort of thing. But again, there are only three or four common options, and in general, things are common because they work and because you can find support. And if somebody says, wow, I've got this cool thing that I just coded up myself and it's awesome, that may be true, but treat it, as Mike was saying, just try to keep the blast radius minimized until you're confident that it works. for the long term.
Yeah,
And
one
at
thing.
least from the system side, for your systems facing folks, if you have not been hooked into ACM, SIG HPC systems professionals, please avail yourself of that group. It predominantly exists as a unlimited history Slack.
Yep.
And at least from my perspective, if I had to go through a lot of effort to get something going, I'm motivated to, make sure nobody else has to go through that same level of hassle. So there's all kinds of little snippets of documentation and other things all through that Slack instance.
Yeah, I'll second that. Our system administrators adore that group and that site.
Chris, you were going to say something earlier?
Yeah, I was just going to say just a little thing, utilizing these free softwares from our community, just be patient with their support and provide kind feedback and spread the word, I'd say.
The other thing I would suggest, in part because I rolled off of being an NSF rotator about a month ago, is not only be kind, but send feedback back to your local or your non-local, but your NSF folks so that they have ammunition to say we really need to support these community science efforts and that sort of thing, because things are pretty grim there right now. And it's nice to know that hey, we did some good, but also just resources are shrinking, and these these long-term science projects or the software side aren't as eye-catching as some of the other things, but they're really, really valuable.
I'd say one of my own experiences recently was having to coach some senior leadership that there are other resources out there, and it's okay if we are sending our researchers to them. We can't do everything for everyone. Let's take advantage of the free resources that we can get to. And, their concern was, are we not doing something here that we should be? And just trying to coach them through, the options for other resources to help facilitate research.
The simple answer is yes, but can you afford to do it?
Yep. I can do everything TAC does. Just give me a budget of 30 million a year, and I'm happy to give it a crack.
Just got a few more minutes here, and we got a couple more questions. I think this is probably one of the last ones here. How do you tie, when you get these donations of hardware or you have these older generations of hodgepodge, non-homogeneous systems, how do you tie them all together to make a service?
So I've been reworking on our architecture here. And so basically I've got like on any key points, like my management nodes, I've got three of these that are actually redundant and they're, RAID hard drives. And then, I just kind of have everything kind of scripted in Ansible so that like when the management nodes are healthy, then they check and make sure that all the other nodes are in place and doing what they're supposed to do. And I just try to have as much redundancy as possible because my stuff is old enough, it's going to die. And sometimes it's going to die for no reason. And so I just try to have everything fail over to the next system. Like Dan said, make them cattle, and that way, if one dies, you just get another cow. Don't They're not pets; they're livestock.
Yeah, we use Ansible, Chef, Puppet, those sorts of tools to automate everything. Do not have systems you need to touch by hand. But on the other hand, we have, I don't know, last I checked, like 36 different, versions of machines out there, just because, you've got everything from Intel i5s up through the latest AMD EPYC, whatchamacallit, and so if you automate it so that when the user hops on, they have their own customized compiled for that particular chip and that architecture software stack, for the most part, they don't notice. Occasionally we'll have an issue with CUDA or something like that because we have a GPU-less CUDA installation on our head nodes where they do their initial compilation and such. But generally, yeah, just automate the heck out of things, which also means and back up your automation because otherwise it is prone to, erasing half of your cluster in a single keystroke. So be careful.
And we also try and look at the whole what's the end-to-end workflow for the users too. So sometimes what we're trying to do is group the machines into resource pools and queues and stuff based on like the CPU types, GPU types, and rough compatibility. But if we get a few oddball things donated, those are often great for things like, hey, I've got somebody that needs a database of a certain type or something to hold their data and so forth. So we kind of try and think about within the architecture where do some of those oddball things are and put them in places where they aren't as apparent to the user, don't have as much impact potentially, or make it as difficult to manage.
In terms of networking, I would say like, compatibility issues, because we get switches from other places. So we don't know like, Arista or Juniper or most of the cases, fs.com, I would say like, FC is turned on, but the interface looks up, everything is up, but there's a packet drop. There's something happening, we don't know. So we need to look about like, compatibility between the vendors itself. Just because it's up doesn't mean that it's actually doing its job, right?
Yeah, I like
Okay.
chat comment about Easy Build. Easy Build saves our hide so much. And we've taken a lot of packages and made Easy Build packages out of them because it's great.
I'll say we had good luck with SPAC so far. That
Same.
was a pain to get.
I never want to build TensorFlow again. Not from scratch. I'm okay. It's gotten better, but
I guess we'll end with question for the panelist here. Either your favorite low cost solution that you've implemented or your favorite resource for helping find low cost solutions for your users to share in chat if you have not already.
So I know for me, the most dependable low cost resource is getting on other people's systems that are already built, paid for, and managed by somebody else, and helping my researchers get to those systems because I never worry about Henry's system being down or Dan's system being down in Texas. I know those systems are always going to be there and I can always rely on them. And so if we do take the time to help somebody get on that, I know that that system's always going to work for them.
Yeah, I'd say almost in terms of avoidance, the more time I spend persuading our users to actually use our system or the national systems, the greater the chances that, their data is going to be okay and that it won't be destroyed when their laptop crashes. Um, we just we just had a user take 200 terabytes off of our system because we were charging them a per month fee. And he bought a 150 terabyte system that he has attached to one of the computers in his lab that he's storing this data on. And it's like, okay, I cannot command you to keep paying me per month, but this is horrific. It's just a single point of failure.
I
So a
think
lot of
for our
times
base,
researchers tend to not realize that the reliability and the availability and scalability aspect of the equation, they just see, oh no, I don't want to pay money for something that I can do myself, but they don't necessarily value the fact that bad things can happen and they're a lot less likely to affect you if you're using a large scale, professionally managed system, wherever it happens to be.
getting out and talking with users, finding out what the requirements are, especially as being as proactive as you can. That's one of the ways too. That's very impactful for the users. You're building the community community, you're getting support for the systems, but you're also saying, oh, this is what they're needing, and being able to help present solutions to them and getting them on board with some of the stuff that you're doing. That's really kind of a good way of building the sport and also helping to bring in the funding for you.
Any others from Sash or Chris? Tom?
I would say like, going after system which are underutilized or undermanaged so that like, it's really good to use like, things very effectively and efficiently rather than just buying new stuff, right? So.
Sorry, can you repeat the question, Melissa?
Yeah, just, sharing, a system that you've implemented that you feel, proud of for a low cost solution, or, a resource that you found helpful to help guide people in finding resources.
Well, Chris is thinking, I'll add that we've loved our Ceph system. We have a RAID 6 NFS system. People can buy it at hardware cost, but no one buys enough storage to double or triple their data. And we don't have offsite data. No one wants to pay for that. And we had a system outage about 15 years ago, lost a HP iBrick system, and two students lost their thesis and all their data. And it's like, you did not have your thesis backed up on like a DVD or something else. Are you crazy? But it was true, and this happens all the time. But getting people to pay or the institution to subsidize the proper backup and offsite storage, it's not happening. I don't think anywhere.
I guess just offhand, just as someone else mentioned before, is reutilizing old hardware for new purposes. And one thing we did was we created a replica of our, well, not a replica, but you know, a bare metal replica of our production cluster out of old nodes and old GPUs, so that we could test updates and test upgrades there, test new drivers, and we can't test everything there, but it's helpful for us to test there first.
Following up on that, one of the things we do particularly on updates is a rolling update. And so it's like, okay, whichever nodes happen to be underutilized now, let's update them. Keep an eye on them. And then, as nodes become free, go ahead and do the updates. But that way there's a little less chance of oh, great, we just wiped the entire cluster.
Yeah, I think some of that might also be just see what you can do to like just make a menu of storage options at different price points, or maybe even if you're lucky, subsidized elsewhere at the university. What I pay per terabyte per power scale is a whole lot different than what we might pay per terabyte for an open science an open storage network pod, for example.
Yep.
They're not interchangeable, but they both store things.
Any last minute questions from the audience? Otherwise, I think we are done. Well, thank you, everyone.
All right, yes, let's have a round of virtual applause for our panel. Thank you so much, everyone. This was fantastic and very valuable information. And we have now come to the end of the Becoming an Institutional Cyber Infrastructure Leader Workshop 2025. So I want to thank not only our panel, but also all of our participants, both those who have been on panels and presenting, and also those of you who have attended. This has been fantastic, and I'm going to throw out my standard joke in these circumstances. If you've had half as much fun as me, then I've had twice as much fun as you. So our hope is to do this often, uh, ideally annually, but we'll see what the demand is for an annual thing. The labor cost has not been too bad, so I think it's manageable to do annually, but I'm not yet promising annually. Of course, we will continue our annual virtual residency workshop, which I anticipate will continue to be in late June every year. And I think working between us and the Coalition for Academic Scientific Computation, or CASC, we intend to continue providing Cyber Infrastructure Leadership Academy workshops as well. Hopefully one per year, co-located with the CASC, I think typically the CASC spring meeting. So we look forward to continuing to see y'all at all these wonderful activities. And let's keep moving things forward. Thank you all so much. And I hope most of you by now have received my next spam for the Oklahoma Supercomputing Symposium on Wednesday, September 17th. So that's 6 weeks from yesterday. So do join us for that. Yes, free, free, free indeed. And we'll look forward to seeing you there for that one as well. Thank you, everybody, and have a great evening.
Thanks, everyone. Good work, Henry.
Thank you so much.
Cheers.